Hello everyone, today we will solve Leetcode 665, which is non-decreasing array. So in this problem we have given an array with n integers and our task is to check whether the given array is non-decreasing or not, and we can modify at most one element. And as we know that non-decreasing means each number has to be greater than or equal to the previous element. So I'll explain this problem over here. So let's say, for example, if you have given array 4, 2 and 3, so I just write in number lines. So let's say 4 somewhere here, then 2 will be somewhere here and 3 will be somewhere here. So the lines will be like this. So we have to see that this one is already right, it's increasing. The only thing is this downhill we have to modify somehow. There is two ways. One way is decrease this number to be lower or try to increase this number, but by increasing this number it's not possible. So the only option is we have to decrease this number. So what we can do is we can take, instead of 4 we can decrease to 0 or any number. Let's say I'll take 2 here. So now it will be similar to like this and like this. So for this example the answer is yes, we need to return true. Let me take another example, 4, 2 and 1. So here 4 is over here, 2 will be somewhere here, 1 will be somewhere here. So if you can see that there are two downhills over here and over here, and just by modifying any number we won't be able to make it non-decreasing, because even if, let's say, if you try to decrease this number anyhow, even if you will make to minus infinite, there would be something like this, right? Let's say you will try to increase this number, so whatever you will do, there will be downhill like this only. And similar for this case as well. Either you try to decrease, then doesn't work. If you try to increase, then again it will be something like this. So in this case, there is no way we can make this array to be non-decreasing by just modifying one number. So the answer would be false. So as you can see that the first intuition by looking at the examples comes to us is we have to see the number of downhills. So in this case, if we see the number of downhills are 1 only, but in this case it's 2. So it seems like if you know the number of downhills, we can conclude this problem. So if we have more than one downhills, we won't be able to make it to be non-decreasing array. But the problem is just downhill won't work here. I'll take one example here, which is, let's say, 3, 4, 2 and 3. So if I try to draw, 3 will be here, 4 will be somewhere here, 2 will be somewhere here and 3 will be here. The line will be something like this and this. So here if you see number of downhills, it is 1, but we can't make it non-decreasing. The reason being, let's try it. So this is downhill, try to modify either this number or this number. So let's say for this number, what you can do is you can try to decrease this. Let's say this is at same level. So what we can do is we can decrease only till here. But if you can do that, still there is a downhill. Let's try to increase this number. If you try to increase this number, so even if you can increase till here, it will be something like this. Still we have one downhill. So we have numbers either way, either decreasing or increasing, we won't be able to make it on non-decreasing array. So what's the problem here? What else we need to check before trying to either decrease or increase the number? So what we can do here is, if you see, we try to decrease the number first. For example, if I'm at here, let's say the first time there is a pattern break. So if there is increasing, the pattern break means if it is increasing like this or equal or like this, so it's like a pattern which we are expecting. But if there is downhill, something like this somewhere, then this is the pattern break. So once there is a pattern break, what are the options we have? So over here, if you think about it, what we can do is we can either decrease this number, either increase this number. There is no other possibility to make this to correct. Then what we can do is we try both the options. So anywhere when there is a pattern break, we try both the options. Let's say I'm trying to decrease the numbers. So what are the conditions we can do that? Right. Let's take the first number to try to decrease. So what are the cases and when we can do this? So let's say this is pattern. Okay, I'll draw again. There is something like this and there is a pattern break. So for this case, if you want to decrease, till what we can decrease? We can't decrease below this number, right? And even after decreasing this to here, if we won't be able to break this pattern, then there is no way to do that, right? It's not a right way to decrease this number. Then we should try for the second option. So how we can decide it? Let's say I'll make it little larger. So and then there is a downhill. So if I want to decrease this number, I know that I can decrease till this point only. Then when this will work, this decreasing this number will work only if this particular number over here is greater than or equal to this number. Because if this number is, let's say this number is somewhere here, then this won't work, right? Even if you decrease this number, still there will be one downhill. But if this number is somewhere here, greater than this or equal to this, then our pattern would be something like this, and then there will be this. So it works. So we have to decide whether we can decrease this number. Let's say the second case is try to increase this. So again I'll take the same pattern, something like this, and there is a pattern break. Now in this case I'm considering this one to increase. So what we can increase and how much we can increase. So in this case, if you want to correct this pattern break, then we can increase this number, but we can increase this to plus infinite. But is it good idea to do that? No, because if you do that to be very large number, then the numbers which are coming after it, let's say somewhere here, then there is a downhill. So till what we have to increase? We have to increase till this point only. Okay. So if this doesn't work, then try for increasing the number, and how long we have to increase till the previous value. Why I'm saying first try for this decrease only? Reason is same, right? If because if you decrease the numbers, then there is a chance that we might correct other patterns. For example, if you decrease the numbers, because we are expecting pattern something like increasing way. So if you decrease the number, it doesn't work. It will be the good idea. But in the other way, if you try to increase first, then it might possible that the next number will fail, similar to this case. Now let's think about whether we need to check these both the things always or not. So if you see the question, it says that you can do only one modification. In one modification, we have two options. Either you can decrease, either you have to increase. So how we see whether there is a pattern break or not? So let me again draw some line. So let's say it's increasing and after some point there is a decreasing. So to check whether there is a pattern break or not, we will check only 2 points, right? Then do we need to modify this number? No, right? Because for the next pattern to check for the next set of numbers to check, let's say next number will be here, and then whether to check is there pattern break or not, we need only these two numbers, right? We don't need this number at all. So this thing which we are trying to decrease the number is not required. The only thing we have to do is just to increase the number. So what will be the solution for this is, see whether we need to increase this or not. But we have to check the condition is if there is a possibility to decrease the number or not. If there is a possibility to decrease is, we think that we have to decrease and we increase count or some boolean variable which says that one time modification has been done, but actually we won't modify the array, because even if you modify it doesn't work, because in next iteration, next time we are choosing next two numbers which are not at all needed. So even if you modify or not, that doesn't matter. So just check the conditions if you can decrease this number or not. If you can, then don't modify anything. And if you can't decrease the number, the only way is you have to increase this thing. So this increase this number to at this level and move forward. I'll show you the solution, but before that let's think about what will be the time complexity and the space complexity for this. So this is a straightforward greedy solution, and we are just checking this each numbers once and some constant operation if else type. So time complexity would be O(n), and we are not using any extra space here, so it will be O(n). Let me quickly show the code. So over here what I'm doing is I start with index 1 because I wanted to check whether there is downhill or not with I-1 and I. So this is the condition to check whether there is downhill or not. I took a modified variable to just make sure that we do only one modification, and next time if there is need of modification, then we'll return false. So if already modification is been done, then we have to return false. And if this condition satisfied and we have to do modification, I'll make it true. And this is the condition. In that case we have to update the current element. We are not thinking to update the previous element, because even if you update it, it will not be useful. So these are the two cases when we need to update the previous element, and otherwise we have to update the current element, right? So this is the case when I'm updating the current element. This condition meets only if decreasing the previous element is not useful here. So the case will be if we have a number greater than 1, because if let's say we have two numbers, first number is 0 index, second number is 1 index. So the first number has possibility to decrease to -infinite, like here. And the second case is if the number is greater than this number. So here what I'm checking is the previous element. I'll show you. So we are talking about the number to decrease. Let's say there is 3, 4, 2, 3. I'll 3 will be here, 4 will be here, 2 will be here, 3 will be here. Something like this. I'll take a example. And here if you are thinking to decrease this number, whether decreasing this number will be helpful or not, it will be decided based on this number and this number. So that's why I use I-2, because if this number is already greater than this number, then even if you decrease this number, it will not work, because there will be downhill. Thanks for watching this video. If there is any query or suggestion, please write in the comment section.